Hello, in this video I'll be talking through the first section from chapter 14, which gives some basic definitions related to circles. So we'll just jump right in. The way we define a circle is in terms of distance. So we start with a point P and we choose some positive number r. By definition, the circle with center P and radius r is the set of all points in some plane whose distance from P is equal to r. So the idea is r is some specific distance. Maybe I go r units away in that direction and I get a point. Or maybe I go r units away in this direction and I get this point. Or in this direction and I get this point. I can go in all these different directions and I get all these different points. There are actually infinitely many of them. I'm drawing them spaced out just so you can kind of get a sense that these are individual points. I'm drawing this a little bit imperfectly, but that's the circle. It's all of these points that are exactly the same distance away from P. And I want to emphasize here that the circle is just the rim. The center is not literally a point on the circle. This stuff is called the interior of the circle. The circle is just the rim. We could define a sphere exactly the same way, but we would leave out the stuff about being in a specific plane. So then we would be taking the same distance in every three-dimensional direction. So this is the same, but without restriction to a plane. And I'll just roll out a little bit of vocabulary here. Concentric means having the same center. So it's an adjective we would use to describe two circles. Here's a circle, has a center. Maybe I have a different circle with the same center. Trying to make this look right. It's not quite perfect, but hopefully you can imagine that these two circles have the same center. A chord is a segment connecting two points on a circle. Remember, point on a circle by definition means the point on the edge there. So it's a segment with both endpoints on the circle. If I take a chord and extend it, I get a line called a secant. So something like this we would call a secant line, or just secant. It's a kind of line. And it's a line intersecting the circle in 2 points. You can sort of think that we're moving along this line. There's a point where we enter the circle and then a point where we exit the circle as we keep going. Chords and secants are very closely related, but one is a segment and one is a line. A diameter is a very special kind of chord that goes through the center of the circle. So if this is the center of the circle and I have a segment like so, connecting 2 points on the circle and passing through the center, we call that a diameter. So it's a chord passing through the center of a circle. Or I might use the word diameter to describe the length of that segment. Right? If I say the diameter is 10, what I mean is the length of this diameter is 10. Radius is also a kind of segment. It's a segment that goes from the center to some point on the circle. So a radius is a segment with one endpoint at the center and one endpoint on the circle. Or, again, maybe I will use the word radius to refer to the length of that segment. Radius is one of these words that we took directly from Latin, so we usually use the Latin plural form, which is not radiuses, but radii. If you say radiuses, it's no big deal, but I will say radii. And I'm just going to give you a really useful fact. It's pretty obvious once you see it, but this is a great fact to just keep coming back to whenever you feel stuck in a circle problem. In a circle, all radii are congruent. That pretty much comes from the definition of a circle. But sometimes it can be really helpful in doing a problem if there are two different radii, to notice that they are congruent and then maybe use something you know about isosceles triangles or congruent segments or congruent triangles. All right. The end of this section has a little bit of stuff related to 3 dimensions. Don't stress too much if you have trouble visualizing this. Theorem 14.1 talks about the intersection of a sphere with a plane through its center. So here's what we're going to do. I'm going to try to imagine a sphere. And don't worry about drawing a picture, but I'm going to just kind of draw this. Hopefully you can kind of think of this as a 3-dimensional object. And we have the center right here. And now imagine that I have some plane that goes through that center. Don't worry about drawing this picture. You can just look at mine. Right? Another way of imagining this, imagine you had like an orange and you're taking like a cleaver and cutting straight through in a way where your slice goes through the center. The shape of that slice will be a circle. And it'll be a circle centered at the center of the sphere with a radius that's the same. Again, maybe not very easy to visualize, but if you could imagine taking an orange or a grapefruit or some round fruit like that, slicing straight through the middle, if you pull it apart, the slice shape is a circle. And the center of that circle is the center of the grapefruit. This kind of circle on the surface of a sphere that has the center of the sphere as its center is called a great circle. It's the biggest possible circle you could draw on the outside of a sphere. And in terms of Earth, great circles along the Earth's surface are actually quite important because those tell us the shortest path for traveling between 2 points on the surface of the Earth. So again, we'll kind of imagine the globe here. I'll draw just a little bit to kind of give us some sense of 3D. And suppose you wanted to fly in an airplane from a point located here to a point located here. Actually, let me move the second one like so. The shortest path would not be the path that looks like a straight line on the map. It would actually follow a great circle. So what we would do, and navigators can figure this out. You figure out what is one of the great circles of the sphere. So it's basically a circle that goes all the way around the sphere, around the center. And then the shortest path would be the one that follows along that great circle. So on a map, it would look curved, but it's actually the shortest path. Okay, so those are just a few preliminaries. The next section will go into a little more detail and introduce some more stuff, but we'll just pause with this.